Hello, welcome to Squarebrain. Today we're going to look at multimeters. Multimeters are used to test and measure various electrical properties, most commonly continuity, resistance, voltage, and current. The multimeter was invented in 1923 by a British post office engineer named Donald McAdee. It was called the avometer because it only measured amperes, voltage, and ohms. Modern multimeters come in a variety of shapes and sizes, but most share similar parts and functionality. Let's break down the parts of the multimeter. The red and black wires you see here are probes. These are also called test leads. The plug ends of probes are standard across most multimeters. The other end of the test leads, or probe tips, might look different. These include needle tips, alligator clips, and retractable hook clips. To be consistent, we will refer to the red lead as positive and the black lead is negative. For all the measurements that we will take with our multimeter, the red probe will be plugged into the middle port and the black lead into the COM port. The only time the red port will be plugged into the top port is if the multimeter is being used to measure current over 200 milliamps. On the top of the multimeter, we have the display where measurements are shown. Most multimeters today have digital numeric displays, but you might still see an analog multimeter. These will have a needle that swings to point to the numeric value that you are measuring. A multimeter is used to measure 5 primary electric properties: direct current, or DC voltage, alternating current voltage, or AC voltage, resistance in ohms, continuity, and DC amperage. The property to be measured is set by positioning the dial on the face of the multimeter. This multimeter has a variety of ranges for each property. In general, for any property that you're measuring, start with a high range value and step to a lower value to get a more accurate reading. Some more expensive multimeters will auto-range the reading of a property value. With multimeters like these, it will automatically detect the level of the property you're measuring and display the correct value. To measure the DC voltage, set the dial to the appropriate direct current voltage range on the face of the multimeter. We'll start with a 9-volt battery. For this battery, we'll position the dial to the 20-volt position. This means it's measuring up to 20 volts. To place the red probe on one terminal of the battery and the black probe on the other. The digital display will indicate the voltage difference between the probes, which in this case is measuring 8 volts. It's probably time to replace this 9-volt battery. The most likely place to see AC voltage is coming out of a wall outlet or at the end of an extension cord. In the United States, our appliances generally use 120 volts AC. But if you live somewhere else in the world, outlets might use a different AC voltage entirely. In Europe, they generally use 220 volts. So let's take a look and measure AC voltage coming out of this plug. Now with the multimeter, we are going to adjust to the AC voltage level. We're going up to 120, so we'll go up to the 200. And then we can take our multimeter probes and we'll put them into the ends, the straight ends of this plug. And as you connect it, you can see it's 120 volts AC. And that's exactly what it should be. Now be sure not to touch this, because if you do, you will get electrocuted. Another useful function of the multimeter is to measure the resistance of a resistor or other components in your circuit. The way to do this is to move the dial down to the ohms symbol, that's the omega down here. And then you're going to touch the resistor with the 2 probes. If you knew the color codes of this resistor, you could tell just by looking at it. But what we will do is we will go down first to this 2000K. 2000K is the same as 2 mega ohms. We then can touch either side of the resistor, and you can see that it reads 268. That's 268 K ohms. That's 268,000 ohms for this resistor. However, many resistors are smaller, both in value and in size. This resistor right here, super small, is called a surface mount resistor. The surface mount resistor, if you touch it, you're going to be very, very careful. it shows 1. That's 1 what? Well, the value is too high. So let's go down to 200K, see if we get something there. Ah, 1K. All right, let's see if we can get a little bit more precision. We're gonna go down, so we know it's about 1K. So let's go down to the 2000. That means we're reading up to 2000 ohms. We touch it there. It's 991 ohms. 991 is just about the same as 1K ohm. Sometimes we want to know that there is 0 resistance between 2 points. We can do this by using the resistance setting and just check what the resistance is between 2 points. And you can see here, the resistance is almost 0. However, the multimeter has a very specific mode for this. It's called continuity checking. What continuity checking does is it makes an audible beep when something is connected. So if I connect these 2 probes together, you hear a nice audible beep. Say you wanted to make sure that a wire was not broken. You can connect the 2 ends of the wire through the multimeter and know that your wire is not broken inside. Let's say you have a whole network in a circuit and you want to say, is my network connected? Just check the ends and you can see your network is continuous or has continuity from one end to the other. As you can see, the multimeter has quite a number of uses. On the top left, we saw how you could measure DC voltages. On the top right, you can see how we can measure AC voltages. Right on the bottom left, we showed how you could measure ohms or resistance. And then at the very bottom, in the little red section, we showed how you could measure continuity using your multimeter. You might notice there are a few other sections that we didn't talk about. On the bottom left, there's a blue circle. This is used for testing transistors. To use this, put it in the HFC mode on the dial. That's transistor amplification measurement. Above that, in the green area, is DCA, and that's used for measuring current through a circuit, or amperes. Now, if you're going to measure a high number of amps, make sure you put the probe into the top hole down below. Otherwise, you'll blow out your multimeter. And the very last thing that this multimeter can do is it provides a 56 Hertz square wave generator. And that's used to facilitate testing of very specific electronic components. Thanks for watching our videos on multimeters.